Hello and welcome to this video, Networking Basics, Packets and Protocols. I'm Wolfgang Tremmel and I run the DE-CIX Academy. This is the first video from my Networking Basics series of videos. If you want to know what the whole series is about, just watch the introduction video. You can find it at the same place like this one. Let's get started talking about networks today. Networks, packets and protocols. This is the title of today's video. And the whole series of the Networking Basics video you can see here, it's going to be continued when I talk about Ethernet, about IP, about the higher protocol layers, but this is all now still strange to you, so let's get started very simple. Let's get started talking about networks. And I'm not especially talking about the internet. There are networks everywhere. If you step out of your door, you're using a network. You're using a network of roads. Here, the network connecting cities with motorways, with cycle paths and with footways. This is a network. It connects places and uses, well, you are using it every day when you step out of your door, the road network. Another network you know and use and have used perhaps, but you are not really aware that it's really a kind of a network. It's the rail network. The rail network connects stations and it uses rails and trains to interconnect stations, railway stations all over the world. Another network, well, I guess you're also using that, that's the power grid, the electrical grid. It connects consumers and producers of electricity. And here we have a clear distinction. Well, nowadays perhaps the distinction between producers and consumers is not that clear like it used to be with the arrival of solar power at home. But the electrical grid connects two types of users, that's producers and consumers of electricity. And another network, well, also not that obvious, it's the postal network. You can use the postal network to send letters and packets. And packets are a good keyword. Let's talk about packets. Well, packets, just imagine you're still at the postal network. And in the earlier days, well, a couple of decades ago, you could have these catalogs where you see interesting stuff which you can order by mail. You can still order stuff by mail, but you don't have printed catalogs anymore. So yeah, the postal network, well, let's say you have seen this garden shed and you've seen it in the catalog, you've seen this nice picture, and now you want to order it and want it to have it delivered to you. So what you're doing, 40 years ago, you wrote a postcard, you wrote a letter, says, please send me this garden shed. And well, like you see, it's quite obvious, it doesn't fit into a single package your postman can handle. So what to do? Well, the sender takes it apart in many pieces and puts it into lots and lots of packages, of boxes, and sends these boxes to you. You unpack it and put it together again. And yeah, and you have a nice garden shed if you didn't make any mistakes by putting it together again. Yeah, and this is the same way like computer networks work. They do not send data in one piece. Nowadays, pictures, movies, they are way too big to be sent in one piece. So it is taken apart, the data is taken apart and put into packets and sent from the sender to the destination. And the receiver puts them together again. And to make this work, we need network protocols. And that's another new term, a protocol. So what is a protocol in the network sense? If you want to communicate with someone, then you need to speak a common language. So if you say Guten Morgen in German and the other party does not understand German and answers in their language, then, well, you don't understand each other, you cannot communicate, communication doesn't happen. So you need to agree on a common language. And here, these two heads, they're now talking English and they can communicate. But the same is true for networks, for computer networks. So the two systems can communicate with each other. They need to speak a common language and they need to speak a common protocol. And on the internet, the protocol devices use for communicating, for talking to each other, this is called IP. IP simply stands for Internet Protocol. And today in use there are actually two versions of IP. One is called IP version 4 and the other one is called IP version 6. In another video of the Networking Basics series, I explain how IP works in detail. If you're interested, please watch it. Another protocol on a network in use, for example at home, is called Ethernet. And Ethernet is the protocol your computer speaks to your router or your networking device in the basement. But hey, didn't I say you're using IP when you're on the internet? Are you confused? No reason to be confused. There are multiple protocols in use at the same time. And this is called a protocol stack. Let me show you a reference model for the protocol stack for communication between computers on the internet and elsewhere. The reference model for the protocol stack, which was defined in the 80s and in the 70s of the last century, was called the OSI stack. OSI stands for Open System Interconnection, and OSI is a project. This was a project at the ISO, and the ISO is the International Organization for Standardization, ISO, International Standardization Organization. And it was defined in the 1970s and 1980s as a vendor-independent network model. At this time, a lot of vendors came up with their own networking stacks, with their own idea how to network. And these network stacks only worked between systems of the same vendor. So the idea was to define a model where completely different systems from different companies could interact. And this was the OSI stack. Yeah, but it never took off. It is still relevant today for teaching, but it is no longer relevant in practice. It was intended really as a real network with software which worked between systems. It had a lot of good ideas, like the separation of layers, of networking layers. And I'm going to talk about these layers today. And these layers, they depend on each other and they build on each other. But while the OSI people were still writing papers and discussing details of their stacks, the internet guys, well, they started writing software and started implementing working, functioning networking protocols. And yeah, what you're using today, are you using OSI or are you using internet? And yeah, despite all the money OSI was getting, internet at the end won. OSI, it doesn't really exist. Some parts of it were put into the internet protocols, but mostly it doesn't exist anymore. So let's compare the OSI model and the internet model. Like you see, the internet model looks simpler, and it is way, way simpler. The OSI model had 7 layers, the internet model only has 5 layers. And also the IP protocols, they don't fit exactly into the OSI layers, and they also were never intended to fit in there. The idea of the internet was to produce efficient running protocols. It was never meant to be compliant to OSI. Running code was most important. Let's start talking about the layers, and we are sticking with the internet layer model because that's what in use today. At the bottom we have the so-called physical layers. Here we are dealing with bits or symbols, so very, very basic stuff, very, very simple types of data. And we are dealing with a physical medium like a fiber or a wire, and on that medium we are dealing with light pulses or with electrical signals. Examples, an optical transceiver transmitting over a fiber or an electrical interface transmitting over a wire. One up, we have the so-called link layer. The data units on the link layer, they are called frames, and the purpose of the link layer is to provide point-to-point, node-to-node data transfer. The link layer needs addresses for the interfaces connected to it, and examples for protocols on the link layer. One I already mentioned, that's Ethernet. Another example would be point-to-point protocol. One layer up, we have the IP layer or also the internet layer. The data units here are called packets, and the purpose of the internet layer is to provide end-to-end transfer. So not point-to-point, not node-to-node, but end-to-end, from here to Australia. And for that, we also need addresses, and well, they are called IP addresses or internet addresses. Protocols on this layer in use are IP version 4 and IP version 6, and we are both using them today. One layer up, we have the so-called transport layer. The purpose of the transport layer is to provide flow control, reliability, congestion avoidance, and also to provide some information about the next layer up. Not all of these features are in use at all protocols. Examples for protocols on the transport layer, one of them is TCP, and TCP, it has all these features like flow control, reliability, and so on. Another example for a protocol on the transport layer is UDP, and UDP has none of these features. It simply only provides some information about the next layer up. Yes, and on the top we do have the application layer. And the application layer, well, this is where all the rest happens. There is no special name for the data units, we just call it data, and it contains all the application protocols. Examples for is SMTP for email transport, HTTP for the transport of websites, SSH for secure login, and all the other protocols are here on the application layer. Yeah, and that's it. And at the end of all of my network basics videos, I have this summary slide. I call it conclusions, and this is really what I want you to remember about today's videos. Networks are everywhere. Roads, electrical grid, and of course the internet. And data across a computer network is sent in packets. A protocol is a common language. Devices speak to each other so they understand each other. The OSI model is a model of defining a network as a number of layers. But the OSI model is just an abstraction for teaching. What we are using today is the internet model of layers. It does not fit exactly in the OSI model. It's simpler, but it is in use today in all internet connected systems. And that's it for today. If you're interested in more information, you can of course download the slides of this presentation, and at the end there is also some additional links with more information you can read and download for further